Hello and welcome to this webinar, talk, whatever this is. My name is Darko, and today we're going to be doing something fun. Today we're going to be looking at enabling compliant development organizations with AWS GitOps solutions. We're going to be talking about GitOps on AWS. My name is Darko, and let's start with a story about disks. A long time ago, I was in a situation where I would need to configure and set up massive amounts of servers. Like, I'm talking hundreds of servers. And there was one step in that process that required me to configure disk RAID, right? Basically mirroring of disks. It used this piece of software that was purely Windows-based, and you can only do it through clicks. There was no way to automate these things. You just had to use your mouse, click a bunch of buttons, and it took you like 20 minutes. There was no way to automate those things. There was no way for me to make those 20 minutes shorter. Hence, if I have 100 servers, think about how much time that takes me. And maybe that was fine 10 years ago, right? But it's 2021. Stuff moves fast. IT moves fast. We need to make changes all the time. You need to bring new versions of software, new hardware, new network configurations, new whatever you have, it needs to move fast. You need to be able to keep up with the pace of change of things. And that is very much important, right? Well, the thing is, when we do things fast, and when we do things manually, when we click around, when we type around, usually new things that are going fast crash, right? So it's not the best of things you want there, right? You know, I think this is one of the first car accidents out there, right? So you can imagine about a situation where I had to do a bunch of disk mirroring on a bunch of servers out there with a bunch of clicks, and I had to do it in a relatively short amount of time. A few of those hundreds of servers would eventually crash because I misclicked somewhere. That's not good, right? And think about other things you may be doing. Think about the urgent patching that needs to be done manually on a Friday afternoon. Or think about a hardware failure that you need to go and replace things. It makes you think, how do we actually do things so fast in the modern world of IT? Well, we do it with code. Yes, code. Code is just great, right? With code, you can codify a lot of things you do, right? From provisioning your infrastructure to configuring servers to configuring compliance, rules, changes, all of those things can be done through the wonders of scripting. No longer do you have to take your hammer with you to provision infrastructure or make changes. No, you can do it all through code, and you can do it all with a single API call. But code is scary. Why is code scary? Code, well, it enables us to do things at scale, it enables us to do all of those wonderful things at scale, but it will also help us screw up at scale. So we need to be able to do those things really fast, but also really precisely. And we need to be confident that the change we do to our infrastructure, the change we do to our configuration, to anything we do, is good. Before I get into the rest of this presentation, allow me to tell you who is this bald person and why is he screaming at you through the power of a camera. My name is Darko Meszaros. I've been in IT operations for most of my life. I was that person with a hammer who was setting up servers and racks. I was patching Windows servers. I was rebooting Linux servers. I was configuring Java virtual application memory setups on servers. And I have a really big passion for automation because of that. I like to automate things. I like to make things move fast. I like to be confident if I hit a button, a thing will happen. And I like to transfer that knowledge and enthusiasm to all of you. I also happen to work for AWS as a developer advocate, and I'm currently based in Berlin, Germany. If you want more of this, check out the social medias, check out the Twitch, the YouTube. You get to see a lot of me as well. And I also come from the lovely land of Serbia, hence the different types of spelling of my name. All right, let's move on to today. Let's move on. What is Darko, me, going to be talking to you about today? We're going to be covering a bunch of topics. We're going to talk about GitOps in general. We're going to talk about CDK, the AWS Cloud Development Kit, and its constructs. We're going to be talking about how to audit and test that code. Yes, you can test your infrastructure code. And we're also going to talk about how to make it move fast with pipelines. Let's start with GitOps. This term is being thrown around left and right. I've heard the term GitOps as much as I hear the term DevOps. And I've even hear people asking me, so what is the difference between GitOps and DevOps? There is no difference. GitOps is one of the cultural practices you have within the entire DevOps mindset, right? You don't buy GitOps, you don't rent DevOps. So, but what is GitOps? I will use a definition from our lovely friends at CloudBees. They have a wonderful, excellent definition of what GitOps is. GitOps upholds the principle that Git is the one and only source of truth. GitOps requires the desired state of a system to be stored within version control, such as that anybody can view the entire audit trail of changes, right? All changes to the desired state of a system are fully traceable commits. Yeah, you all always know who is that committer and when and how that commit made. This means that both application and infrastructure and a few other things are versionable, are versioned, that's the word, are version artifacts that can be audited and can be tested against using your gold standards of development and delivery. That's it, right? In essence, it means that anything you do, any of these things should be inside of a Git repository. Any change you make to your infrastructure, right? No more hammers. Any infrastructure as code push you do, any change to configuration, all of those things should be in a repository. All of them should be automatically deployed. All of them should be rollbackable. You should be able to roll back the changes you made because you will flip to a previous version of a thing. So that's the whole point of GitOps, right? Everything needs to be in a Git repository. Which Git repository you're using doesn't matter. To be honest, it doesn't even have to be Git. It needs to be one of the code repositories out there, some version control system you need to have that you can automate to a certain point, right? In essence, the goal of GitOps is that whatever change you make to your infrastructure, whatever change you wish to make to your configuration, anything inside of your system, it needs to be done through Git push. That's it, right? So think about it right now. Instead of going and changing your favorite EC2 instance type by going to the console, clickety-click, and changing the type, or even going to your CloudFormation code and changing it and going to the CloudFormation, clickety-click, make that change in your favorite text editor and do a Git push. That's it. Now why? Why this? Why Git push? What's wrong with me clicking? There is absolutely nothing wrong with clicking. But with the use of Git push, or a proper software delivery lifecycle, you can apply the best practices to software delivery, to infrastructure delivery, to configuration delivery, to compliance, or any kind of thing you want to do on top of your system. This means having it in a repo. This means getting it into a pipeline. This means testing that code. Testing the code that you push should also be a part of your provisioning lifecycle, let's call it that way, right? And it's wonderful because it gives you this peace of mind that, yeah, I have made this change to my template, to my script, to my compliance code, and I will be sure that it will execute properly and it will be tested against. And if something goes wrong, I can automatically roll back. And for me personally, I like this because it helps me do everything within the command line. I can deploy my entire infrastructure from this Commodore 64 right here. Wonderful, right? So maybe not the point, but that's the thing I like. Just to mention, GitOps is not just about infrastructure as code. And I know these terms are being used left and right, and they're being, I wouldn't call them abused, but it's sometimes difficult to pin down what each of these things is. But GitOps is not just about provisioning your infrastructure. It's also about configuring your infrastructure. It's also about having your compliance out there as code. Basically anything that you can codify. Your standard operations, your playbooks, your whatnot, your config files, your testing code as well is code, and it needs to be provisioned through the power of GitOps, and well, through the power of Git and pipelines in essence, right? So that is GitOps. Basically, all of the desired state of a system needs to be in a version control system, which can be audited, traced, and well, versioned. Now, let's talk about something else, very much related to GitOps, and one of the things that can help make your entire GitOps thing a bit better. Let's talk about CDK constructs. Now, I'll get into a moment what CDK is, but when it comes to CDK constructs, actually, when it comes to infrastructure provisioning, right, we talk about infrastructure as code. You have your CloudFormations, you have your Terraform, Pulumi, CDK, serverless, SAM, all of those things. And we usually, what happens is you write your infrastructure code, you use those specific properties and resources and configurations out there, and you expect that each of your developers uses those things in a specific way. Now, you can test against that. You can make sure that the developer is using it a specific way. For example, let's say you want to create a specific combination of EC2 instances, S3 buckets, and SQs, right? You can instruct your developers to follow a guide saying, hey, if you want to create this specific thing, here's the guide, here's the code, here's the examples you need to use and how they need to be connected. Or you can provide them with the building block. I'll talk about that in a second. First of all, what is AWS CDK, aka Cloud Development Kit? It is an open source software development framework, basically, that helps you model and provision your cloud applications. I wouldn't call it infrastructure, but cloud application resources. Anything you need on the cloud can be done with Cloud Development Kit, right? Anything that you need to provision on the cloud can be done with CDK. And what's wonderful about that, you can use your favorite programming language to do so. So you can see that you have your Pythons, JavaScript, TypeScript, Java, C#, and Golang. I believe Golang is in preview, well, it's available. You can use it, right? So it's wonderful because you can use all of these tools. You can use all the best practices connected to these tools, testing code. You can use your pipelines. You can use your linters. You can use your favorite text editors that support all of these things. And it's just wonderful. It's great. It creates these, constructs, reusable classes, all of these things that can help, well, build your own building blocks. What do I mean by this? I mean creating a set of configurations, right? Set of resource properties, set of best practices for a specific workload, right? I mentioned this. Let's say you have a service that requires 4 EC2 instances, 2 SQS queues, and a database. Instead of getting the people to do it themselves, getting your developers to write those things and telling them, hey, for this thing, you need 4 EC2 instances, 2 SQS queues, and a database, why not create this little bundle that just provisions this workload X for you? And the developers, instead of having to reinvent the wheel and build those things, they can just use it, right? But why? Developers like building code. Developers like writing, and it's their favorite language, right? Well, you want to make sure you standardize. We always boil down to making things reusable, right? I joke that using CDK to build constructs, it's making Lego out of Lego, but you make a special Lego for this case, right? You make a special little thing that you kind of plug into the rest of your system. So, and it's not just a matter of like, it's easier to plug in, it's standardized, right? If we say any S3 bucket created in our system must have notifications enabled on every upload, and must have encryption enabled, then get your developers to create a construct that will create such a bucket, and get your developers to use only that piece when they desire to create an S3 bucket. Wonderful, right? You can standardize, you can implement standard practices to your infrastructure development with CDK by the use of CDK constructs. And what's wonderful about this is that, I mentioned CDK supports your favorite language. CDK supports something called JSII. Basically, JSII helps translate your CDK code into numerous other languages that are supported, right? Let me actually show you how this works. So you get your developers, you get your architects to write this specific construct, let's say this S3 bucket with notifications and encryption. They write the code, they test it, they do all of these fun things against, in their workstation. But they do it in TypeScript. But a specific other group of people you work with uses Python or uses Java or uses C#. Do you have to rewrite your construct all of those times for everybody? Well, no. JSII actually is able to generate code. It can generate code that can be later on pushed into, any of these repositories, and then it can be reused by this package. So you create your piece of code, let's say in TypeScript, you run it through JSII, it will generate your Python constructs, your Java constructs, your anything, right? All of those things will be generated by JSII, which is just wonderful, right? It's great because it eliminates the need to rewrite things into multiple languages. So, and I think it's just an excellent piece of technology in this case. So you write your code, you write your construct. Here's an example of a bucket with encryption, right? You test your code. Yes, it's TypeScript. You can use your what is it called? The Jest framework for testing your code, for example. You can do all of those things. And also configure your JSII that will ultimately provision your code to one of those repositories, right? So in essence, you can have this custom resource, custom construct that you've built available in repositories that developers around your company can just pick and choose and reuse. But you know what? Let's have a look at some code, right? I've been talking a lot. I think it would make sense for me to actually just show you some code instead of talking too much in this case. Let me flip to this thing. All right. So let's have a look at the CDK construct that I've written that basically does the things I've told you. It creates an S3 bucket with notifications enabled and encryption. So I am currently in a directory where I have my custom construct. Now I've used a tool called Proyen or Progen. I'm not sure how to pronounce that thing. Proyen, that basically will create this entire folder structure with it, right? So I think I'll put a link somewhere here or on the screen or whatnot about that project. You can check it out. It's wonderful. It does a lot of the heavy lifting for you. But the core is still CDK, right? If I open up my file here, src main.ts, src please. All right, you can see that this is my specific construct. And what's wonderful about this thing is that it actually extends the construct. It extends an existing concept within CDK, right? So, and you can see that things that I've done here are basically just creating a bucket, which exports these two resources, these two properties, and it accepts a specific property. And everything else is just your typical S3 bucket here, right? It's a typical S3 bucket. The only thing I have done here is enabled encryption. I want to have my bucket encrypted. And also I've set up a couple of additional things that can automatically delete this bucket with CDK and, all the stuff. And additionally, I have an SNS topic created. That's it, right? This is a construct. If you would later down the line use this construct in your code, this will be created basically with a single new statement. That's it. So I won't get into the details what the exact every line of code is doing here, but basically it creates an S3 bucket with encryption, and it creates an SNS topic that on every object created, every time somebody uploads an object to this bucket, it will notify a given email address stated here. Now, I mentioned testing. Let me have a look. Let's go to tests. There's a test here. It's using the jest library here, right? And it's basically just doing a bunch of unit tests. It mocks an application, it mocks a stack, it passes it a specific mail here, and it expects that it has an SNS, for example, an SNS subscription with this specific email, right? This is your standard software testing. So I can test the code that will provision my infrastructure in the future, which is just wonderful, right? These things should be part of your infrastructure delivery. And all these things. So now if I do yarn build, it's gonna basically build all the files that I need here, and I can use later down the line within my actual project. Now, this is going through the entire testing process. Finally, I need to do a yarn release, so it will basically update, so it's not running all the tests. So later on, I have to run yarn release, so it will release the proper version of my package, which I can later on upload to NPM, for example. I'm not going to do all the JSIS stuff here, but it's basically doing a bunch of that stuff as well within, and this is all done by ProN, which is wonderful. See, it's running a JSC PackMac, so all of these things can be packaged now and can be ready for me to deliver. So yarn release, I believe that's the command. Yep, it's running ProN release. Basically, it's going to be cleaning up a bunch of stuff. It's going to be bumping up versions here. You can see that the version has been bumped here, right? So this thing here, and yeah, it is going to finish all of these things, well, once it runs all the tests. Okay, let me actually show you this in action. How do I actually use this piece of code in an actual CDK project? So I have here a simple CDK project, nothing else. It's just simple CDK application. But if you look at my package.json, you will see that I am actually using this specific module, right? And I have not uploaded it to NPM. I am basically just using the local file path here. Nothing special, just using a local file path. If this was on NPM, I could have just used basically the NPM package name, and NPM would pull this package for me, but I'm not doing that right now. So I'm including this. If I would run npm install, it would basically pull it from the local directory. But then the important thing is I go here and you see I create a simple stack. That's all fine, but this is it. With these 3 lines of code, with what you see here, this is creating all of those things. It's just creating a bucket with basically from this module. I didn't have to define my SNS configuration here. I didn't have to do any of that. It's all basically in this little module, and it's being run with a single new statement here. That's it. The thing you see on the bottom here, this is just output. Just I want this thing to show me my bucket name. That's it. This is all it takes. Now I could have entered all of my bucket configuration here. I want my encryptions. I want all my things, or I could have just easily, just used an existing thing, use the little piece of code that will define all this. And of course, this can be as complex as you want. I could have made this not just a bucket. I could have made this entire workload, entire complex set of things, your 4 instances, your SQS, all of those things, and just put them in here. That's it. All right, let's go back. So your own building blocks. Basically, it's reusable code. It helps you build things that are tailor-made for your team, organization, company, whoever you work with, to kind of build specific things in a concrete, specific, safe way. You can use all of your best practices for code development to have a lovely standardized Lego made out of Legos, and it's blazing fast because I had to enter only 3 lines of code to create this compliant, well-structured piece of infrastructure instead of having to do it all manually. Now, another question. You've seen the code. It's fine, right? It looks okay. I've run a test. I made some unit tests. But how do you know does your code do what you want it to do, right? I mean, you can look at your code. You can say, that code looks fine, I guess, right? I can see that it does my bucket encryption. I see that it uses a SNS topic, all of these things. That looks perfectly fine. You can even go to like your CloudFormation console to see, has it created things that you wanted? Has it created the resources that you want in the way you want? But that's not fast enough. And it's tedious, right? You don't want to have to manually go and check things. And we're engineers. We automate things. We like things to happen automatically in a pipeline we don't care about, right? So there are ways that you can actually automate the checks. I'm not talking about testing your code. I'm talking verifying, will the code do what I want it to do? And there's a bunch of tools out there that can help you with verifying, are you following the best practices? Are you following specific rules you've set for yourself? And ultimately, does it work? So let's talk about number one, AWS CloudFormation Guard. There's a version 2.0 released relatively recently, so there's a bunch of changes in there. But what CFN Guard is, or CloudFormation Guard, is just a wonderful example of policy as code. What this does is basically lets you define specific policy, specific way you want your resources to look like, and have it test that. That's it. So think about your CDK code. Every time you deploy your CDK code, it's in essence CloudFormation. It compiles to CloudFormation. And what CFN Guard can do is actually verify that compiled output and see does it apply to your policy. Let's say I want a policy that says all of your S3 buckets need to be encrypted. It can check for that. If you want a more, let's say, agnostic option, Chef has a wonderful tool called Inspec. Inspec is just amazing. It can not only do your infrastructure testing, like verifying is the bucket encrypted, it can also check things on operating systems. Inspec can actually run on top of an OS and check is Telnet installed. In this case, you can see the example here. It will test that Telnet should not be installed, right? And this is actually used once you deploy your infrastructure into a staging environment or whatnot. Inspec can go through and say, hey buddy, you actually have Telnet installed. Your system is not compliant. And it's all through code. It's amazing. You can push this to a repo and have this automatically deploy. Also, when you're writing your code, for example, you write your CDK, you go through all of the stuff, or even if you're writing CloudFormation, you can use something like CFN-NAG from the lovely folks at Stelligent. CFN-NAG will basically detect potential insecure infrastructure. Let's say I have created an S3 bucket or a security group in my CDK adventures, and I just run it. What CFN-NAG will say, hey Darko, you're allowing everybody to access on port 22. Maybe you should not be doing that. And you can also, again, define your own rules here. It's wonderful. Again, open source tool that helps you check these things. And all of these things are actually sitting in a pipeline somewhere down the line and testing your code, the code that your developers will publish as well. But let's actually have a look at some of that code. I like showing code. All right, so we've seen our CDK thing here, right? We've seen our stack being used. Well, actually, let me just show you. CDK deploy. I've not tested this, so let's see if this works. Boom, boom. Yeah, there you go. It's gonna deploy my CDK code. That's fine. But one of the things I could have done here is I could have actually went to CFN. I could have actually used CloudFormation Guard to verify a couple of things. So let's open up, I have a directory here called CFN Guard, and you see here there's two files. There's the guard file and there's the test file. So if I open up the guard file, you will see that it's basically looking at S3 buckets, right? It's looking at S3 buckets, and it has a rule that it needs to have a specific encryption algorithm enabled. In this case, I am allowing AES 256, and what it does here, it basically makes sure that encryption exists, and yeah, and that it finds SSC algorithms, basically this server-side encryption algorithm within the allowed algorithms. That's it. It's a really nice way of, I wouldn't say enforcing things, but basically defining policies regarding your templates. And if I had 100 buckets in this CDK template, it will check all of those buckets to make sure they have this. Now, this is not doing anything on your account. It's basically taking the artifact, the CloudFormation template produced by CDK, and running it through CFN guard. Let me actually show you. I think I have a CFN guard. There you go. So this command, as you see here, let me show you. So this we are running validate, right? It's validating a template. Which template? Well, this template. What happens here? CDK synth synthesizes your CDK code into CloudFormation, outputs it to standard out, and then it's picked up by CFN guard, and it's testing it against this rule. That's it. So this is what's happening right now. So if I clear the screen and I go do this, if I can, I should be able to do so. Okay. CDK synth, come on. App is okay. Oops, one more. You need to go one level up. There we go. And it's passed. So we can see here that this thing is successful because it has, this rule has basically is compliant from the template. That's it. So if I had multiple rules, if I had all of those things here, it would also be able to check those stuff. So wonderful, wonderful. Just let me show you one more thing. The test. There's also a test. You can actually have a test to test the tests, to test the guard files, to test the policy. So you can actually apply a way to actually test if your policy passes. It's weird. So let me see if I can have the CFN guard. It's not rule gen. It's not validate. Once CFN guard. It's test. There you go. CFN guard test. There we go. I'm basically going to be testing this template. That's it, right? It's testing. Does my test work? And you can see here that it does a bunch of things. It verifies that this is passed, and it is validated to pass. It's expected to fail. It has failed. This is expected to pass, and it has passed. There we go. Testing all the tests, apparently. All right, go back to this thing, and now we can go back to the presentation. If I can. Come on, where is my thing? My keyboard died. Okay, so we've seen an example of testing your code with CFN guard, right? Wonderful way of testing. Is the actual produced template the thing you want? But do you use it like that? Do you use it in your command line? Yeah, you can. You absolutely can, just to verify are the things the way you want it to do. But you usually use it somewhere else. Because you got to go fast. And when we say about going fast, we talk about pipelines. Yes, of course, pipelines. And this is where we get into the topic of how does GitOps actually work with CDK or CloudFormation or your infrastructure as code? Well, as you can see a couple of examples here, this is where your Git push happens. This is where your CDK code is changed, all of the stuff you've done. You bring in your modules, your constructs, all of the fun things you want, and it goes inside of a repository. It goes to your code commit, it goes to your GitHub, GitLab, Bitbucket, whatever kind of a code repository you want. Then it hops onto the pipeline. This is the pipeline. The pipeline is the thing that takes your code from position A all the way to prod. Right? That's a bad prod. it does that, right? And this pipeline actually takes your code through a bunch of different steps. It goes to, for example, code build. It's a wonderful tool that doesn't just build your code, it basically runs arbitrary commands against an artifact you give it. And in this case, the artifact is your CDK code, well, CloudFormation code in this case. And what it does, it actually runs all of these things against it. Runs your CFN guards, CFN lints, task hats, it runs your chef inspects. All of these things are being done here to validate, is the code you're running the code you're running. And then once that is done, it basically goes onto a test stack that is basically creating a CloudFormation is creating a change set, then promoting that stack to staging, and then finally what we all want is production. Right? The thing is, all of these tools here, this is where you do your testing, and this is what kind of enables you to understand, is the thing I'm launching the thing I'm launching? That's it. You have your code here, the standardized code, the custom construct. You have your Git push here, and then from there on it goes down this entire pipeline, ultimately into production. Okay, but it's not just infrastructure. It's more than just infrastructure, right? It is also your configuration, right? So it's your infrastructure, it's configuration, it's compliance, it's your test. You do all of the stuff here through the pipeline. Now, these tests here might change. Let's say you're using Chef to configure your systems, your operating systems. You would push it through a pipeline, and you would have code build. Instead of running your CFN lins, CFN nags, you would run test kitchen, for example, right? For example, you would run, if you have your inspect files here, you want to make sure to test your tests, right? You want to test your inspect files. You can actually test your inspect files also through a pipeline. You want to do config rules. You can use the rule development kit in the pipeline to actually test your rules, which is wonderful. So again, it's not just about provisioning EC2 instances, Lambda functions, buckets, or databases. It's also about configuring operating systems, pushing compliance rules, and also your tests. All right, let's move on to a thing. If I can find, that's it, there we go. All right, let's wrap it up. I've been talking too much. What is GitOps? Well, it basically makes the single source of truth for anything you do in your system, your patching, your infrastructure, your configuration, your operations. The single source of truth for that is a code repository. That's it. You have a workflow that basically takes the provisioning of those things through a pipeline, tests against it, make sure it all works. You have your compliance stuff there as well. But it also is rollbackable, right? You can roll back the changes because it's all version control, right? It's defined. It's you have a desired states defined somewhere, which, well, is provisioned through the means of CI/CD. And because you have a desired state, you can also detect potential drift. What I mean by drift is that if you define that your infrastructure needs to look like this, but for some reason somebody made a manual change, with all the tools in your GitOps and DevOps portfolio, you can actually detect drift. CloudFormation drift detection is one of those. And also, it's not just infrastructure. Again, it's infrastructure code, it's your configuration code, it's your compliance and policies, and it's your security code and tests, and all of those things are code. And all of those things should not be on your workstation, just on your workstation. They should be in a Git repository. So remember, do not click Git push. With that, thank you very much. My name has been Darko Meszaros. I really hope you enjoyed this little presentation here. I'm a fan of talking about these things. I love automation, and I love when things go smoothly and I don't have to care. Like, imagine a Friday afternoon, me typing in there git push and just going away, because I know that all of my tests should catch all the problems. Yes. But yeah, thank you very much. If you want to reach out, please feel free to do so. So I think my thing is here. Yeah. Reach out to me on social media, wherever you find me. And yeah, I really hope you enjoy this presentation, and I will thank you for watching. Bye.